here we are with Stats 8.5. So, first, a little bit talking about causation. So when collecting data, statisticians are often interested in making predictions. Sometimes statisticians simply want to know if one variable explains another variable. Oftentimes, statisticians want to determine if one variable actually causes a change in another variable. Given the examples below, decide whether you think the variables simply explain each other or if you think one variable would cause the other to change. So, question 1. As the amount of food Ollie the elephant eats increases, her weight also increases. So, does that explain or does that cause? Now, here's the thing to think about. With causes, it's, you've got to be basically 100% sure that, pretty close to that it causes. So, I guess, is there anything else that could also cause weight increase? That would be kind of the question to ask on that first one, to answer it. I think you could kind of say, if Ollie the elephant doesn't eat, she's definitely not going to gain weight. So I think that's one that you could probably say is a cause, though it isn't necessarily always just that. So, number 2, and really, we should probably go with explains on that, because, you could eat more, but work out more, do stuff so that eating doesn't necessarily increase your weight, if that makes sense. So I don't think we could say it causes, because not everybody that eats more always gains more weight. As popsicle sales go up in the summer, the number of drownings also increases. So, would that cause it or explain it? Well, it definitely wouldn't cause it, right? No way that buying a popsicle means you're going to drown. But it could kind of explain it in the sense that, well, if more people are buying popsicles, it's probably warmer, which means more people are swimming, which means there's more likelihood that people are drowning if there's more people swimming. Number 3. As Erica's feet grow longer, she grows taller. So, I guess, can your feet grow longer without growing taller? I mean, typically if you grow taller you have bigger feet, but that's not necessarily true. So I think really, I don't really feel that you can make that a cause. As Tabitha gets older, her reading score improves in school. Once again, just because she's getting older doesn't mean she's going to be reading better. So really I would put explains on all of them, because there's not really anything that would be necessarily a cause because of it. And it's really tough. When you're talking about causation, it's really tough to prove causation. So, let's keep going. For the following scenarios, identify the population, sample, and parameter of interest. Remember, population, what's our total group? Sample, what's the group we're actually talking to? Parameter, what do we want to know about the group? So, the local school board wants to get parents to evaluate teachers. They select 100 parents and find that 89% approve of their child's teacher. So, our population would be parents. The sample was 100 parents. The parameter, evaluating teachers. Kind of like that panorama survey we did earlier in the year. Number 6, Jarrett wants to know the average height of the students in his school. So what does he want to know? The average height of students in his school. Okay, there are 753 students in his high school. He finds a height of 52. So the sample, 52 students. The population, 753 students. Number 7, a government official is interested in the percent of people at JFK Airport that are searched by security. He watches 300 people go through security and observes 42 that are searched. So the population was 300 people, 42 people were the sample. The parameter is, percent of people searched. Alright, so now, taking a look at these ones, something happened on the homework apparently, and on my version of the homework, I don't even have A or the parts of this, so don't worry about answering these ones, okay? Just cross those ones out and let's move on. Now, we are going to talk about those different types of ways to gather data, right? Okay, now, when we're talking about question number 2, when we're talking about the these methods, alright, picking up where we left off. When we're looking at this one, we're dealing with either calling them observations, surveys, or experiments. So, A. To determine whether drinking orange juice prevents colds, researchers randomly assign participants to a group that drank no orange juice, or a group that drank 2. So here they're trying to control. Remember, experiments are all about controlling what's happening to try to understand. So that would be experiment. B. To determine whether exercise reduces the number of headaches, researchers randomly selected a group of participants and recorded the number of hours each exercised and the number of headaches. So here they're not controlling, they're simply observing, so observation, null study. C. To determine the effectiveness of a new advertising campaign, a restaurant asked, it's kind of a key right there, every 10th customer. So that would be a survey. Okay. D. To determine if a new drug is an effective treatment for flu, they select 2 groups. Okay, so we got 2 groups, so it could be an observation, it could be experiment. One was given a placebo, and the other was the new drug. So this right here, they're controlling, so an experiment. E. To determine if higher speed limits cause more traffic fatalities, researchers compared the number of traffic deaths on randomly selected stretches of highway, so they're observing, so it's observation. Alright. Now, 3. Describe how you might select a sample and use a survey to investigate which soft drink people prefer, soda A or soda B. So, you're taking a survey, right? So, you could do like they often do at stores. Set up a table, have the 2 drinks, A and B. Now, what kind of sample would we probably be looking at there? And remember, when we're talking about the different ways to do samples, there's simple random, where you're just randomly choosing from a group. Systematic sample cluster, where you're picking groups. Stratified random sample, where you are splitting up the groups and picking the random ones out of that. The convenience and volunteer. So it'd probably be either convenience or volunteer, correct? That's probably what I'd go with. Most likely it's just the people that are coming into the area where you're at, so I'd say probably a convenience. So you just ask people, have them, and so it may even be considered a volunteer instead. Which people volunteer to actually try it. 4. Describe how you might select a sample and use an observational study to investigate which soft drink people prefer. So here, maybe you would go to stores, grocery stores, convenience stores, and see of soda A and B, of how many total customers come in, how many are choosing this, how many are choosing B. So here, maybe you'd be some sort of cluster, okay, or a stratified random, where you pick these stores in different areas of the city. 5. Describe how you might select a sample and use an experiment to investigate if consuming large quantities of soda A causes headaches. Well, we'd have 2 groups, right? One with soda A, one with a different soda, or placebo. And for here, you'd want to get a little bit more, you wouldn't want just a simple random sample. You would want either systematic or stratified, so that you can go with those and pick a large different, you want a cross-section of people. Okay, so if you chose to do it at the high school, maybe you would do something like, we would look at every single English class, because pretty much everybody has English, and you could choose either the cluster, you'd choose classes, or you could choose the stratified certain people from each class. I'd probably go with the second. 6. Describe the method you would use to determine if excessive texting causes bad grades. Explain why you chose that method and what conclusions could be drawn from the study. I want you guys to work on that one yourselves. Okay? Think about what you can do there, what methods, how you would look at it, what would be a good way to do it. Okay. So, once again, we kind of combined two homeworks here, so that's why some of these look like repeats. So we're talking about surveys, observational studies, and or experiments again. So to determine if a new pain medication is effective, they randomly assign two groups. Usually when it's got two groups, and especially when one is given a placebo, that's an experiment. They want to determine if raising the speed limit will have an impact. So they watch or observe, okay, so observational. These are some quick ways that you can kind of take a look at it. 15. To determine if a new sandwich on the menu is liked more than the original, the manager of the restaurant takes a random sample of customers that have tried both sandwiches and asks them which sandwich they prefer. So asking what they like, survey. 16. Once again, they're asking customers, so it's a survey. Alright, now, Mrs. Goodmore wants to know if doing homework actually helps students do better on their unit exams. Describe how she could carry out a survey to determine if homework actually helps. Okay? So, maybe something like SurveyMonkey, right? And just have all her students take it. Or, if she didn't want to ask all students, which is probably what I would do, because most likely she doesn't have a ton, how would you randomize that design? Okay? Well, the randomization would have to deal with who you're asking. Because if you asked all the A students, you're going to get a different result than if you ask all the F students. So you need to make sure that you randomly choose students that fit along all of those different grades. How could she carry out an observational study? Number 18. Well, that would be, in your grade book, looking at who did homework, how much homework they did, and what, grade that resulted in. That would be an observational. 19. How could she carry out an experiment? Well, she could maybe do it with two classes or split up a class. This class does homework. This class doesn't. And then we compare grades using that normal curve. Would be a great way to compare those grades and see where we end up. So, 20, I want you to decide which do you think would be the best method and why. Remember that you're looking at if doing homework actually helps students. And then we can kind of answer that one. If you do a survey is all about how people feel. That's not actually, some people feel that doing homework does help, others don't. So I don't think that would be accurate because it's more based off the feelings. Observational could possibly work. I would probably try to go with an experiment, though. If you really want to look at cause, you have to control things, so you'd have to do some sort of experiment. Because an observation can tell you that there's a correlation, but it can't tell you if there's causation. And that's what you're trying to figure out here. Alright, so let's take a look, kind of review some normal curves here. So the average resting heart rate of a young adult is approximately 70 beats per minute, with a standard deviation of 10. Okay, so let's draw and label the normal curve. So I'm going to do that down here. So we've got our curve, right? The mean, which we said was 70 beats. 1 standard deviation, 2 standard deviations, 3 standard deviations to the left and to the right. Obviously, I'm not the best at drawing normal curves. Okay, and standard deviation of 10, right? So as we go higher, we'd be 80, 90, 100. Lower would be 60, 50, 40. Alright, so that would be, we got all that one done. 22. What percent of people have a heart rate between 55 and 80 beats per minute? Okay, so 55 would be right about here, correct? And 80 would be right here. Remember that when we're talking about these intervals, and we had 68% here. So these are basically 34% and 34%. If we looked at the further out we went, then we went, 2 standard deviations was 95, like 0.44 or something like that, 95%. So 95 minus 68, there's 2 different ways we can do this. I'm showing you the first way. Would be 27. 27 cut in half would be 13.5. So these are about 13.5% from 1 to 2. 13.5. Well, 55 is halfway, so what's half of 13.5? Would be 6.75. So 6.75 plus 68 well, I totally messed up ordering that, didn't I? So 68 plus 6.75 would be 74. Basically 75% of the people have their heart rate there. Now the other way you could do it would be to find the z-scores for each one. So 80 minus 70 over 10. Okay, so that would be 10 over 10. So you'd end up with 1. And then you would look that up on the z-score table, which I don't have. And then 55 minus 70 over 10. So that would be what, negative 15? So negative 1.5. Okay, which makes sense. 1, that's the 1 standard deviation, right? So it would be 1.00. Negative 1.5, it's 1.5. So you'd end up with the same basic idea. Okay, then the last one, 23, if a resting heart rate above 80 beats per minute is considered unhealthy, what percent of people have an unhealthy heart rate? Well, if we go up here, okay, and think about all these pieces, okay, when we go out to 3 standard deviations, that was, 99, like 0.7%. So, above 80 would be all in this area. Okay, so 99.7 and 95, if we're looking for what percent is right here and right here, 99.7 minus 95 would give us 4.7. Cut 4.7 in half, that's like 47. It'd be what? Be 2.35. So 2.35, 13.5, 34, 34. And I know there's probably another decimal in there. 13.5 and 2.35. So if we add these up, and then this is like a really, really, really small decimal, you're basically at about 15.85, so about 16% of the population would have unhealthy. Interestingly enough, 2 summers ago I went and got a physical. My resting heart rate was lower than 40. It was like clear down here. They had to, while they were doing the heart monitor, actually it was like right at 40. I was like 3 standard deviations away, basically. So I was in a small percentage. They made me have to, because my heart rate had to be at a certain rate, high enough to be cleared for the work I was doing. They made me like run in place and then hurry and take my pulse and that. So it was kind of interesting, kind of weird. So anyway, there we go, guys. So yeah.